Hi, I'm Mary, and this is another magical math moment. This video is designed for our Algebra 1 students, and maybe Algebra 2 if you need a little refresher on linear systems of equations. So in this video, we're going to be looking at solving by the elimination method, which will include addition and multiplication. There are other videos that I've put up about solving by graphing and also substitution, so feel free to check those out as well. Okay. The whole goal with elimination is to find or create a pair of opposites. And so what I mean by that is that you could have a term, maybe something like 10y, and its opposite would be negative 10y. Okay, so the values are the same except for the sign. One's positive, one's negative. So if we go ahead and look over here, we have x minus 3y is 7, and 3x plus 3y equals 9. Hopefully you're noticing we do have a pair of opposites, negative 3y and 3y. When you have a pair of opposites, you can cancel them, combine what's left. X plus 3x is 4x. Don't forget there's a 1 out there. 7 plus 9 is 16. From there, you're going to divide by 4 on both sides. This will cancel. 16 divided by 4 is 4. Now, you get the choice as to which equation you can substitute back into. I normally like to choose the ones that are positive, but you could do either of them. So I think I'm going to go ahead and do that, because why risk a sign error if you don't need to? The second equation says 3 times something plus 3y equals 9. The something is 4. 3 times 4 is 12. And we're going to copy the rest of the equation. I'm solving for y, so we'll subtract a 12 from both sides. Watch your signs. 3y equals negative 3. And then we divide both sides by 3. To get that y equals negative 1. Finally, write your answer as a point. 4, negative 1. Don't forget the parentheses around it. Remember that the solution of a system is where the lines intersect if you were to graph them. Okay? Let's try another one where it's a little sneaky. Okay, so this time I don't have a pair of opposites. I do have some opposite signs here, but 2 isn't a factor of 3. So if I'm going to try to eliminate anything, it's not going to work very nicely. Hopefully, you're seeing that I have a 2x and a 2x. If this were a negative 2x, they would cancel. So let's go ahead and multiply a negative 1 into that 2x. Remember, what you do to one term of an equation, you have to do to all of them. So negative 1 times 2x is negative 2x. Negative 1 times negative 3y is positive 3y. And negative 1 times negative 13 is positive 13. So I'm just going to recopy that equation after distributing in that sign. Okay. Next, we're going to go ahead and cancel out those opposites. 2y plus 3y is 5y. 7 plus 13 is 20. Next step is to divide both sides by 5. 20 divided by 5 is 4. Again, I'm not trying to deal with the negatives unless I absolutely have to. So I have 2x plus 2 times y equals 7. The y value is 4, so I'm going to substitute that in up here. 2x plus 8 equals 7. Then we'll subtract the 8 on both sides. I get 2x equals negative 1. Be careful when you divide by 2. This is negative 1 divided by 2, or negative 1/2. Don't say it's negative 2. That's a common mistake, all right? It's negative 1 divided by 2. You could also say negative 0.5, but I tend to leave things alone as fractions because I can. So we've got negative 1/2 4, or negative 0.54 if you really want to use decimal. Okay. This is a super sneaky one because when you look at this, there's no opposites and there aren't even numbers that are the same. What's even worse is that I can't multiply 3 by anything to get 5, nor can I multiply 2 by anything to get 3. So in this case, we have to multiply both equations by something. I find the easiest way to do this is just to take the leading coefficient of the first equation and bring it down to in front of the second. And then also take the leading coefficient of the bottom equation and bring it up. Check real quick in your head to make sure that when you multiply these, you have an opposite. 3 times 5x is 15x. 5 times 3x is 15x. So I need to make one negative. Let's make the 3 negative. We're going to go ahead and distribute that in and also distribute in here. Negative 3 times 5x is negative 15x. Negative 3 times 2y is negative 6y. And negative 3 times negative 3 is 9. Underneath we have 5 times 3x, 15x. 5 times 3y, 15y. 5 times 9 is 45. If you've done this correctly, you should have a pair of opposites, which I do with my x's. Combine what's left. Negative 16y plus 15y is 9y. 9 plus 45 is 54. Then we can divide both sides by 9, and y is 6. I'm going to choose the second equation because there's no negatives. I have 3x plus 3 times y equals 9. The y value is 6. 3x plus 18 equals 9. Next, I'm going to subtract 18 on both sides. 9 minus 18 is negative 9. And then we'll go ahead and divide by 3. Negative 9 divided by 3 is negative 3. So our solution to this one, let me get a different color, is negative 3, 6. I hope that this video has been helpful for you in understanding how to use elimination to solve systems. Please, if you like it, hit that like button for me, and also feel free to share this with your classmates and friends. Subscribe so you can get more amazing algebra videos. Thank you so much for watching, and I'll see you next time. Bye.